So for example, if you're given Sx is 19.696, Sy is 33.479, Y bar is 161.111, and X bar is 17.222, and R is 0.997. Then B is equal to 0.9997 times 33.479, and you get 1.695, and A is equal to 161.111 subtract and you get 131.920. So you get an equation of y hat equals 131.92 plus 1.695x. The calculator can also give you the equation of the line. So first you put all the data, the given data, you put the explanatory into L1, and you put the response into L2 in the list. Then you go back to the original screen, you press Stat, you go to Calc, and you press 8, which is linear regression A plus BX, and then enter. What you get is an A, a B, an R squared, and an R. The R squared is the coefficient of determination. It tells us the proportion of the variation in y that is explained by the least square regression of y and x. So if we get an R squared of 0.70, that means that 70% of the variation is accounted for by the regression line. After we get our equation, we can interpret it. So the slope, which is v, is the rate of change, and it tells us how much y hat changes when x increases by 1. The intercept, it tells us the value of y hat when x is 0. When we interpret the pattern of the scatter plot, we also have to look for deviations by looking at the residuals, which is the distance. So residual is equal to the observed y minus the predicted y. It helps us, after we get the residuals, we can make a plot of a residual plot. So a scatter plot, you can just turn it because you're looking at the vertical distances. So when you make a residual plot, you take the distances and you just plot it. And it'll basically look the same as if you're turning it. It helps us assess if a regression line is appropriate because regression lines are only useful for data with linear trends. Large residuals means that this is an outlier. The problem with the residual plot is that it does not show outliers in the x direction. So there can be an outlier way out, but close to the line, and the residual plot won't tell us. But this is also called an influential point because it will affect the direction of the regression line.
Chapter 5.1, Designing Samples. This chapter is all about sampling, surveying, and experiments. Sampling, taking a small sample from a big population. Surveying, asking questions. And experiments, using treatment to get results. This distinguishes from observational studies. Observational studies, observing an individual and measuring variables, and it does not influence responses. An experiment also imposes some treatment as well on the individuals so we can observe their responses. Okay, sampling from populations, we have many methods. The first method is voluntary response. This is when people choose themselves as the respondent. SRS, simple random sample. All you do is wait, can you see this?
No.
Okay, good. First, you choose an SRS by labeling, and then you use a table to select the members from the random digits. Third one is stratified. Third one is stratified. You divide the population, then you choose an SRS. And the fourth one is multi-stage. It's a cluster of individuals, and each stage may use any sampling. Failure to use probability sampling results in bias. Four types of biases are under coverage. This is when people are left out from the population sampling. The second one is non-response. This is where people do not cooperate, or they can't be contacted. Third type of bias is response. This is where the behavior is bad. For example, lying. That's bad. And the last one is poorly worded questions. Just remember, larger sample equals more accuracy. The end. That's it.
Alright, so we're doing chapter 5.2, which focuses on
designing experiments. Okay, so the main purpose of experiments is to reveal the response of a variable. It's important to know the distinction between explanatory variables to figure out the factors in an experiment. Alright, wait, pause it. Okay, let's talk about comparative experiments. These type of experiments have a simple design. Which can be depicted as units. Then you separate them into treatment. Then observing the responses. In these types of experiments, there could be confounding variables, which can give misleading results. So by comparing two types of experiments, you could get rid of the presence of confounding variables. Okay. You could do this by setting one group as a control. Control meaning that they don't really get any treatment, and